Hi, this is CJ here bringing you a little how-to video. Okay, so what we're going to do is take a look at systems of linear inequalities. This is from Unit 4, and specifically we're going to go to page 157, number 16. And the direction state graph the system of linear inequalities. We have three equations here. Okay, so we know we have to graph these things. What's the first thing we need to do to be able to graph things? Well, when we had to do similar stuff like this with equalities or equations, the best thing was to get it into the slope-intercept form. Y equals mx plus b. So basically what you need to do is the first step is solve each of these inequalities for y. Okay, let's take a look at that. See, step 1, solve each inequality for y. So here we go. 3x minus 5y is greater than or equal to negative 15. We have to solve for y, isolate y, subtract 3x from both sides, minus 3x, and we get negative 5. Y is greater than or equal to negative 3x minus 15. Divide both sides by negative 5. What you do to one term, you do to every term divided by negative 5. Now here's the trick. So negative 5 divided by negative 5 is 1, so we're going to get y. But remember, when you're dealing with inequalities and you multiply or divide by a negative number, you have to change the inequality around, okay? So, and a negative divided by a negative is a positive, so it's going to be 3/5 x. And negative 15 divided by negative 5 is going to be positive 3. There we go. Now we have it in the slope-intercept form, where the slope is equal to 3/5, and b, or the y-intercept, y-inter is equal to x equals 0, y equals 3. That's that one there. So we do the same thing here. We're going to subtract 6x from both sides, minus 6x, and we get y is less than negative 6x minus 2. It's set. There we go. So the slope equals negative 6 over 1, or we could say the slope equals 6 over negative 1. And the y-inter is equal to 0, negative 2. Now, this one's already set up. Y is greater than, it's already solved for y, so we don't have to do anything there. Yeah, my dogs are barking in the background. They're being playful. So, step number 2, we just have to graph each inequality. Well, what I'm going to do is, this is, I'm going down here because it's the simplest one. Y is greater than 0. I mean, here it is here, y. Here is the, here's the x-axis, but the thing is y is greater than 0, so it's everything above the x-axis is y is greater than or equal to 0. So basically we draw a solid line. Well, my pen is out of control. Draw a solid line along the x-axis, both arrows in both directions. And this is the graph that represents the inequality here. Okay, this is it right here. Boom. Okay, so here it is here. And then it's going to be everything above here, and including the line, okay? That's why it's a solid line, okay? So let's just work our way up the, it doesn't matter, we can do either one, but I did equation number 2 next. So we know that the m, or rise, remember it's rise over run, or it's the delta y, the change in y over the change in x, okay? And for this, for equation number 2 is equal to negative 6 over 1, or it could be 1 over, oh, no, it could be 6 over negative 1. And then the y-intercept is 0, negative 2. So you just graph that point first, 0, negative 2. Here it is right here. And then you go let's use this one here. It's pretty easy. We'll go up 6 and we'll go up 6 and to the left 1, because that's what it tells us. X over y. So we'll go 2, 4, 6 and to the left 1. There are 2 points. We'll connect the dots. Let's look at the next graph. So here it is with the dots, and it's connected. Now it's less than, so it's a It's a dashed line. So now we have everything above here. And so we have to figure out for this one, it says less than. Y is less than. Well, take a look at the y-axis here, right? If we go up the y-axis, what happens? The numbers get higher and higher and higher, right? 8, 10, 12, 14, 16. Is that less than? No. Less than is going down this direction. Look at that. It's getting smaller and smaller and smaller. So that means we have to be looking at this side of the inequality because it's everything less than. See how that works? Well, look how this is shaping up. Look at where they're converging. They're kind of converging right here. Okay, so now we need to take a look at this inequality, number 1. And so we know the slope, m, is 3 over 5, or the rise over the run, and the y-intercept is 0, 3. We'll graph the y-intercept. Let's see, that's 2, 3. That's this point right here. Let me maybe use the ballpoint pen, see if that, oh, that's blue, that's not going to help. We'll use the highlighter, okay? Oh, that's really big, we'll just stick to this. But anyway, here's the point right here, and it's 0, 3, and then it's go up 3, right, and to the left 5. So we'll go up 1, let's see, 3, 4, 5, 6, and oh, to the right 5. 2, 4, 5. Oh, that's another point there. Okay, so let's take a look at what that graph actually looks like, and it'll be nice and clean. So here is the graph of y is less than or equal to 3x, 3/5 x plus 3. And since it's greater than, look, we go up and down the y-axis. So it's got to be everything on this direction, right? Boom. And we know this is coming down here. And we know this is coming up here. Boom, boom. And we know that this, oh, it's less than. I'm sorry, I made a massive mistake. It's less than, it's coming this way. That's not accurate. So what's going to happen is they're all going to meet right here in the middle. See, because the green line is going to the left, the yellow line is going down, and the red line is going up. Let's take a look at that in a nice. And so this is what it actually looks like here. Okay, here's the solution. It's that point there, that area in the middle there where it's a common solution for all 3 inequalities. Okay, so hopefully you found this to be helpful.